What are stabilizer codes in quantum error correction? Imagine trying to keep a delicate glass sculpture safe from tiny vibrations and bumps. In quantum computing, the sculpture is the quantum information, and the bumps are errors that happen during calculations. Stabilizer codes are a special way to protect this fragile information. They are a key part of making quantum computers reliable. These codes work by spreading the quantum information across many physical qubits, which are the basic units of quantum data. Instead of storing the information in just one qubit, they encode it into a larger group of qubits. This way, if some of the qubits get disturbed, the overall information can still be recovered. Think of it like spreading a secret message across multiple pages so that if one page gets damaged, the message can still be read from the others. At the heart of stabilizer codes are operators called stabilizers. These are special mathematical tools made from combinations of Pauli matrices, which are simple operations on qubits. The stabilizers are chosen so that the correct, encoded states stay unchanged when these operators are applied. These states are called the code space. They are like the safe zone where the quantum information lives, immune to certain errors. To find out if an error has occurred, stabilizer codes use additional qubits called ancilla or stabilizer qubits. These interact with the data qubits and are measured to produce what is called a syndrome. The syndrome is a pattern that reveals whether errors happened and sometimes which errors they are. Importantly, measuring the syndrome does not directly disturb the quantum information itself. Instead, it gives clues on how to fix errors without destroying the data. Once the syndrome is known, classical computers analyze it and decide what correction operations to perform. These operations are then applied to restore the quantum state to its original form. This process is essential for building fault-tolerant quantum computers, which can operate reliably despite noise and imperfections. Many well-known quantum error correction codes, like the 7-qubit Steen code and the 9-qubit Shear code, are stabilizer codes. They are popular because they are easier to understand and implement compared to more complex codes. They also fit well with current quantum hardware, making them a practical choice for real devices. However, stabilizer codes do need a lot of physical qubits, sometimes dozens for just a few logical qubits, and requiring complex circuits for syndrome measurement and correction. Despite this, they remains the main method used in quantum hardware and software to keep quantum information safe. In short, stabilizer codes encode quantum data into many qubits, use special operators to detect errors indirectly, and help correct those errors without harming the information. They are a vital part of making quantum computers work reliably and are a foundation for future quantum technology.